This is Jack Jackson. Today we're going to be looking at the proof of the angle-side angle triangle congruence theorem. And this theorem says that given triangles ABC and DEF with angles A and D congruent and angles C and F congruent, and also AC equals DF, so the two red sides are congruent, then triangle ABC is congruent to triangle DEF with that correspondence. So, what are we given again? We're given this angle is congruent to that angle, this side is congruent to this side, and then this angle here with the two blue marks is congruent to that angle there. So we're given angle, side, angle. Now, can we prove that these are congruent? Well, we're going to use the side, angle, side postulate to do that, but we don't have that information yet. So here's how we're going to, so this involves a nice little technique that we're going to do. Okay, so the first step we're going to do is we know that there exists a unique point G on ray DE. We don't know where it is on here, but it's somewhere on this. So if this blue distance from D to G is congruent to the blue side up here. Now where we want to show is that eventually that has to be this point E. But at this point we don't know that it's point E. It could be down here, here, here. We're going to show that it eventually has to be there. So we have to prove that. Now, what do we have now? We have that AB and DG, this blue side is congruent to that blue side. We also have this angle here at D and angle at A are congruent, and the two red sides are congruent. So by side, angle, side postulate, the triangle BAC has to be congruent to the triangle GDF. Okay, so those two triangles must be congruent. Okay, well, what does that mean? That means all the corresponding parts are congruent. In particular, it means that this angle right here, this angle DFG is the same size as the angle ACB. So we have to move this up and down until this angle matches. But we already have an angle here, so this point G must be on this ray, and it also has to be on this ray here, and of course they only intersect in one point. So in fact, point G is the same as point F. It has to be right there. And we've proved that. So, what do we know? We've already proved that triangle BAC is congruent to triangle GDF, but GDF is the same as EDF. So we have proved the two triangles are congruent.